Alright, now we get into the meat and potatoes of the CCNA. In the second part of this fourth module, we're going to go ahead and talk about subnetting. Now, I'm going to go ahead and warn you that this is probably the most important presentation in the series, and so if there is stuff that you are not clear on by the end of this presentation, you'll need to be 100% clear on that before you continue on with the CCNA trainings. This is very, very important. So important, in fact, that I actually have an entire slide dedicated to saying how important it is. I mean, seriously, the CCNA requires you to be a very fast, efficient, and good subnetter, and you ought to be able to perform subnet calculations with very high speed and very high accuracy. So I encourage you, again, I provide a lot of materials on the Facebook group, so you should go back, you should do these exercises. There are entire appendices devoted to subnet practice, so you should be able to practice these and come up with problems for yourself. Try to figure out some of these things. Figure out what addresses work and don't. But again, this is very important, so I highly encourage you to practice this as much as you can. Alright, so now we actually can break down what an IP address is. Basically, every IP address consists of a network portion and a host portion, and so the network portion is going to be determined by the first octet and what we call classful addressing. Classful addressing, basically, the first octet, the number before the dot at the very beginning of the IP address, will determine the size of the network portion and the size of the host portion. And so for a Class A address, the number at the beginning will be a number between 1 and 126. And if this is the case, then the network part is actually only the first octet, that number 1 or 126. And the other three octets, the last three numbers in the IP address, will be used for hosts. In the case of a Class B address, we'll actually use the first two parts, the first two octets to determine the network, and the last two will determine the host. And so, for example, Wichita State uses the IP address range 156.26, and that would be considered the network, the classful network. And so all hosts on the Wichita State network will begin with the two octets 156.26, and you'll notice that 156 falls in this range listed here, and therefore is a Class B address. The final class is the Class C address, and those are going to be all addresses from 192 to 223. So, for example, the ever-famous 192.168.1 would be considered a Class C network. And you'll notice I said the first three octets there because the first three octets are considered the network portion. The last octet is reserved for hosts. And so the number of hosts in that Class C network, the number of the first host is going to be 192.168.1.1, and then the last host is going to be 192.168.1.254. Why don't I say 255? 255 is the highest possible value you can have in an octet. We'll talk a little bit about that here in a second. So now I want you to look at this list of numbers, keeping in mind that the address ranges go from 0 to 255, and see what's missing from the list above. Try to figure it out yourself and do a little bit of research before you pause the video and then keep going. So 127 is removed from this, and actually 127 has a special purpose. It's reserved for local loopback addressing. You'll recall when I talked about inter-process communication, when I talked about Layer 7, the whole point of Layer 7 is designed to be from one process to another, and that may or may not be across a network. While they can use an IP address to talk to each other, they may just end up using different IP ports or different TCP or UDP ports on the same loopback address. And so 127 is reserved for these internal loopback addresses. And this interface, this loopback interface that is on a computer will almost always be up, and it's used primarily for inter-process communication. Another range that we're missing here is the range from 224 to 239. And that is reserved for IPv4 multicast. These can be considered, I'll put Class D in parentheses out there. It's not really a class because there's no network portion or host portion in a multicast address. It's simply referred to as a multicast address. And so it could be anywhere between 224 and 239. And there are several different addresses, Class D, some sort of multicast addresses that we'll talk about over the course of these presentations. The last range is from 240 to 255, and that's reserved for future use. It's Class E. You probably won't see these implemented. You may eventually end up seeing these implemented for some later IP networks. Now that we're kind of running low on IPv4 addresses, you may see some of these used. And the highest address, where all of the octets are set to ones, is considered the IPv4 broadcast address, and this will be not only sent to all particular hosts in a particular network, but this is also sent to all networks. And so IPv4 broadcast is all ones, just like an Ethernet broadcast was considered where the MAC address is all ones. So now we can talk about some special IP addresses that are reserved. And so the IP address where the host bits are all set to 0 is considered the network address. And this isn't assignable to a host. It is something that network engineers use to refer to the network. For example, when I was talking about Wichita State networks earlier, I was talking about the 156.26 network. Well, the actual network address that I would use to refer to that network would be 156.26.0.0, and that would be the network address for Wichita State. Another address that's important is the address where all the host bits are set to 1, and this is considered the broadcast address. Again, using that same example, Wichita State's broadcast address would be 156.26.255.255. That's setting all of those host bits to 1. Again, neither of these two addresses can be assigned to any particular host on the network. They're reserved for these sort of special purposes: network address for network identification, and broadcast address for broadcast communication between hosts in the same network. So here's some example. If you wanted to look at the host 192.168.4.5, we'll look at that first octet, and that first octet tells me that this is a Class C address. And if you're not sure where I'm getting that, go back and look at the previous slide, and then look at the first octet on this address. And so that last octet is considered the host bits for this particular address. So if I set those host bits to 0, I get the network address. That's the second one listed here. And if I set those host bits to 1s, I get the broadcast address that's listed here. And so these are both very important addresses. So if a particular host, let's say 192.168.4.5 wants to send a broadcast to everybody on the network, it can send a broadcast to 192.168.4.255, and all hosts on that local network will receive that address. And so real quick, what I want you to do is I want you to pause the video here in a second, and I want you to go through and look at each of these 5 IP addressing examples, and I want you to look at them and determine what class they are, and where the network and host portions fall in each address. So go ahead and pause the video now. And for those of you coming back, what this is, so looking at the first address, the first one based on that 4 is going to be a Class A address, and so the host portion would be considered the 4, the network portion would be considered the 4, and the host portion would be considered the .2.2.2. For the second one, the first octet there is 192, so our network portion is going to be 192.0.2, and the host portion will be that .55 at the end. For the third one, the first octet is 6. This tells me it's a Class A address, so the network portion will be just that 6, and the host portion will be that .7.8.9. The fourth one's kind of a trick question. If you'll remember, I talked about IPv4 multicast addresses residing in that space from 224 on up to, I don't remember the higher address off the top of my head. However, this 224.0.0.1 is a Class D address. It's a multicast address, so there is no network or host portion in that address. Finally, we come to the last example, 172.16.34.83, and the 172 tells us that this is a Class B address, so the network portion would be 172.16, and the host portion would be 34.83. So now that we've talked about the classful addressing scheme, we need to move to something called the classless addressing scheme. Basically, networking sort of exploded, and people wanted to find a way to take these large networks. For example, 10.0.0.0 is a Class A network with a lot of hosts. If you look at that, we have 3 octets that we can use for bits. And so what some networking people wanted to do is they wanted to divide these bigger Class A networks into smaller networks called subnetworks, or subnets for short. And basically, we can specify the portion of the address the bits that are being borrowed for the network portion as the subnet mask. And basically, the subnet mask is going to tell us explicitly what portion is the network portion and what portion is the host portion. And in this case, we can actually write network masks a couple different ways. Subnet masks can be written in .decimal notation, which you'll commonly see on Windows machines and quite a bit on Cisco iOS, or you can do it in what is considered CIDR notation with a slash and the number of bits. And these two examples are actually equivalent to each other. Basically, by specifying the network mask, we actually now have three portions. Before, we only had a network and host portion. But because we can look at the network mask, we can actually borrow additional bits besides the allocated bits or the allocated octets from before to be used for the network portion. And so we'll have a subnet portion of our address as well. So I'm actually going to give an example of subnetting here in a little bit, but when we're analyzing subnets, these are some things we'll want to look for. First, what is the original classful network that we're talking about? To find this, you would simply look at the first octet. It's very easy. Second, we'll want to look at how many subnets are possible for the given subnet mask. And so remember, we're borrowing some additional bits in addition to the bits that were allocated for the network portion by the original classful network. We're now looking at borrowing more bits to be used as the network portion. And so, based on that number of bits, how many possible subnets could we have? And then for that, we'll use look at the number of bits used for subnetting. So in CIDR notation, it would be that number after the slash, or in a dotted decimal, you'll have to do the conversion. After we do that, we'll want to subtract the number of bits that we used for the network portion. So for example, if we have a class A address, that would only be 8 bits used for the network portion. And so we'll take from our subnet mask 8 bits. The remaining bits, the remaining n bits, are dedicated to subnetting, and based on those n bits, there will be 2 to the n subnets available. And there actually is an exception to that we'll talk a little bit about here in a second. The last thing you'll want to look at when you're analyzing subnets is how many possible hosts can be contained on each subnet. This is a very similar process. We're going to look at the number of bits in the subnet mask, and then we're going to subtract this number from 32 this time, instead of subtracting from that number the number of bits used for the network portion. So we're going to end up with 32 minus the number of subnet bits, and those last m bits, the remaining bits, are reserved for hosts. And in this case, we actually have to subtract 2, and the reason we do that is because of those special addresses we talked about. The network address, which is at .0, and the broadcast address, which is at .255. And so, just doing some initial analysis, let's go ahead and have a look at this particular example. And so we have the address 172.16.1.1 with a 255.255.255.0 network mask. So looking at this, I've went ahead and converted this to binary for you. And you can see that speaking in binary terms, the subnet portion of this address will end up being the logical AND, or the binary AND, of the first thing and the second thing, of the address itself and the subnet mask. And so if I AND the address with a subnet mask, it will give us 172.16.1.0. This would be considered the subnet. Now, real quick, just as a test to yourself, what is the CIDR notation for this subnet mask, 255.255.255.0? What would the CIDR notation be? Just kind of note that to yourself. And you need to be very good at converting between these dot decimal notations, like that are displayed here, and CIDR notations, like what I showed you earlier, and be able to go back and forth between them. And so you can see here are some examples of this conversion, and you can see the /8 would be considered a class A address, and in terms of a network mask, that would be written in dot decimal notation as 255.0.0.0. And you can see some examples here, and you'll notice that as we add more and more ones, as we borrow more bits for the network portion, we get these different numbers, these different sort of nice even numbers. So 128, 192, 224, 240, 248, 252, 254, and finally at the top 255. And you'll notice that pattern repeats from one octet to the next as we add more and more bits to the subnet mask. And so I would encourage you to be familiar with these subnet masks, and I would encourage you to memorize this pattern, this recurring numbers between 128 and 255, as you'll probably find those very handy when you're doing network masks that are not as nice as the ones that I've done in my examples here. For example, if you have a subnet mask 255.248.0.0, you're not going to have a chart to tell you that that's 13 bits. You're going to have to do the math yourself. And so, looking at this address, doing a little bit of further analysis on it, we can actually notice that the entire third octet is being borrowed for subnets. The reason I say this is if we look at the class of this address, the original classful network is going to be 172.16.0.0. And you'll notice that if we look at our network mask shows 3 octets are dedicated to the network. So in this case, we've actually borrowed the third octet to be used for this particular subnet. And in this case, we could actually have a number of different subnets. We could have 172.16.0.0/24. We could have 172.16.1.0, which is the network that we're actually talking about in this case. You could also assign 2.0, and so on, all the way up to 254.0, and finally 255.0. And so what I'm talking about here, these are not hosts that I'm talking about. These are possible subnets. Each of these is actually their own individual network that is basically a portion of that bigger 172.16 network. And so the 0 and broadcast subnet, you'll see I have designated there. We'll actually talk about those here in a little bit. So to look at this address overall, just to give a final overview, this particular address and subnet mask pair, the network, the original classful network, is going to be 172.16.0.0. Again, that's going to be determined only by the first octet. If we're looking at the particular subnet, that's going to be determined by the subnet mask. And so looking at that, we actually see that we've borrowed 8 more bits. We've borrowed an octet. We've borrowed the third octet in this case. And that's going to be 8 more bits than we used in the original network. So that's going to give us 2 to the 8th subnets. And in this case, the particular subnet that we're talking about here is 172.16.1.0. And in this case, the number of hosts per subnet is also 8. Why? Because we have 8 bits left in the network mask. You'll notice that that 0 at the end is going to be 8 bits worth of zeros, and so 2 to that 8 bits of zeros minus 2 because of the network and broadcast portions will leave us with only 254 hosts in this network. So we're taking the bigger network, 172.16, and we're dividing it into 256 different smaller networks. In this case, this particular host resides on this 172.16.1.0/24 subnet, and that subnet could contain a total of 254 possible hosts. This one happens to be .1. And so this particular host happens to be .1. Now I'm going to talk to you guys about 0 and broadcast subnets. This is one of the pickier things in the networking world. So originally, when the standard first was released, there was an RFC that was released that prohibited the use and configuration of the 0 and broadcast subnet. What do I mean by that? That is the subnet where the borrowed bits, the subnet bits, are all set to 0 or all set to 1. I'm not referring to the host bits here. I'm referring to the borrowed bits. And you should go back and look at the previous slide if you're not sure what I mean by that. I actually did a quick example of what the 0 and broadcast subnets were. Now, these subnets can actually cause problems with classful systems, so I discourage their use, but in fact, by default, Cisco iOS devices will allow you to use and configure these special subnets. The IP subnet 0 command is applied by default. This is not something you actually have to type in. This is something that modern routers will automatically apply. You won't even see it in the configuration just because it's automatically there. And so subnet calculations can actually be performed in one of 2 ways. If you were borrowing n bits, you can do the traditional calculations where you remove the 0 in broadcast subnets, which will give you 2 to the n minus 2 subnets. Now you'll notice that's not the calculation that I told you guys to do. I told you guys just to do 2 to the n subnets. Now why is this? The IP subnet 0 command allows you to use the 0 and broadcast subnets in your network. And so these subnets are freely available to you. There's no restriction on whether or not you need to use these. So in all of your calculations, you should naturally assume, unless you were told otherwise, that all subnets are available to use and that the 0 and broadcast subnets are unrestricted. Again, do not use the traditional method unless you are explicitly told that either the IP subnet 0 command has been removed with no IP subnet 0, or if you're told that the 0 and broadcast subnets are unavailable to you. That just about wraps it up for this first presentation with respect to subnetting. I've actually got another subnetting presentation in the next module, but we're going to move on to a different topic in the next one. So again, leave comments if you have questions for me, and I hope to see you in the next presentation.